Hey guys, welcome to another Algebra 2A video. I'm back. It's lesson 1-8. We're going to explore transformations. We're not going to do as much work in transformations this semester as we normally do, but we are going to touch on them, and I think today is as good a time as any to discuss them. A transformation is a change in position, size, or shape of a figure. You guys did this stuff in geometry. You did translations. They're sometimes called slides. You did rotations. You did flips, which are actually what we call reflections. And then you did what we call dilations in geometry. They're called stretches or compressions. In algebra, it's the same kind of idea. So probably the easiest one to talk about is a translation. And a translation, or a slide, is a transformation that moves each point in a figure the same distance in the same direction. So basically, if I want to take this point to -1 and I want to move it 4 units left, I'm just going to take it and I'm going to slide it over 4 units, just like the name. And so from 2, -1, it goes to -2, -1. And if I want to move it 2 units right and 3 units up, I can do that. I can move 2 to the right, 3 up. So I go from 2, -1 to 4, 2. Notice that when you translate left or right, the x-coordinate changes, and when you translate up or down, the y-coordinate changes. So this leads to this general formula, and it's also on your note packet here. Basically, horizontal translations, like so, we are affecting the x. And we use the letter H to denote the change. So this one here is moving 3 units to the right, so I'm going to add H. If H is a negative value, you're moving to the left. Basically, you're subtracting. And if H is a positive value, you're going to move to the right. You're adding. For a vertical translation, we are affecting the Y, and we use the letter K. I like to think H for horizontal and K because there's a K sound in vertical. They probably don't use V because it looks too much like Y. But basically, same idea. If you're adding, you're moving up. That means K is greater than 0. If you're subtracting, you're moving down. So K is less than 0. So there's that. Now, if we go back to the text, basically that's this here. The next concept is what we call a reflection. And you can reflect over anything. You can reflect over a line, you can reflect over a point, but we're going to reflect over 2 very specific lines in most of the translating we do, or the transformations, I should say, and those are going to be the axis. So moving from left to right, a horizontal reflection, you're reflecting over the y-axis. The y-axis, the vertical axis, acts like a mirror. So what happens here is x changes sign. We go from positive to negative. If you are reflecting up to down, a vertical reflection, you're actually reflecting over the x-axis, the horizontal axis, and you're changing the y. So again, if we go back to our notes here, when it says reflect over the y-axis, that is actually horizontal. And the x value, make it negative. When we reflect over the x-axis, I know the x-axis is the horizontal axis, but it's actually a vertical reflection because we're moving from up to down or down to up, and the y changes sign. All right, the last type, and I'm not even going to go back to the textbook, we'll just do it right here, are what we call stretches and compressions. Stretches, obviously, are making things bigger, and compressions are making them smaller. So you're thinking bigger or wider. Here we're making it smaller or more narrow. I don't know if narrower is a word, so we'll just say more narrow. So horizontal changes, When it's a horizontal change, again, we're changing that x coordinate, we're multiplying it by a value. We say the absolute value of b has to be greater than 1. The reason why it's an absolute value is because if it were negative, not only would it be a stretch, it would also be a reflection, because if you remember what we just talked about, changing those signs. So we say absolute value. For vertical, you change the y. And again, you're multiplying, and a has to be greater than or equal to 1. And it's an identical operation for compressions, except now your b value for x or your a value for y is between 0 and 1. It's a fraction. It's less than 1. Fractions obviously make things smaller, and things that are greater than 1 make things larger. So let's take a look at some of this stuff, and let's see if we can't figure it out. Perform the given translation on the point 2,5 and give the coordinates of the translated point. All right, so we're always going to use 2,5. All three of these questions we're using 2,5. You're going to use whatever point they give you in the homework. 3 left is horizontal. So basically what I like to do is I like to write my rule. xy is going to become x minus 3y. So that means that my point 2,5 is going to become 2 minus 3, 5, or negative 1, 5. If you get into the habit of writing out the rule, then life's going to be a lot easier, trust me. So down is a vertical change. So what are we doing? xy is going to become, let's see, we're going to do x and y minus 6. So same point, 2,5. We're going to go 2 and 5 minus 6. So 2, negative 1. Last one here, we're doing 2 things. So we got x, y, and the rule here is right 4, so it's going to be x plus 4, and up 2. It's going to be y plus 2. So we're doing both things. So 2,5 is going to become, let's see, 2 plus 4 is 6, and 5 plus 2 is 7. And that's it. It's really, once you get the hang of this, it's not really very difficult at all. All right, so here we have this function, this weird looking w. We're going to move 1 unit left and 5 units down. So 1 unit to the left means I'm going to do x minus 1. 5 units down means it's going to be y minus 5. So let's see. Negative 3 minus 1 becomes negative 4. Negative 1 minus 1 becomes negative 2. 1 minus 1 becomes 0. 2 minus 1 is 1. And 3 minus 1 is 2. For the y's, 3 minus 5 is negative 2. 1 minus 5 is negative 4. 2 minus 5 is negative 3. 1 minus 5 is negative 4 again. And 2 minus 5 is negative 3 again. So these outside values are our new points. So we got a point negative 4, negative 2, negative 2, negative 4, 0, negative 3, 1, negative 4, and 2, negative 3. So let's see. Negative 4, negative 2 is going to be right there. Negative 2, negative 4, right there. 0, negative 3, right there. 1, negative 4, right over there. 2, negative 3, right there. So basically, we got that going on. And even though my drawing isn't perfect, the shape doesn't change. When we translate and move stuff around, we're not changing shape. We're just changing location. All right, stretching and compressing. Vertical stretch by a factor of 3/2. Vertical stretch means we are multiplying the y value by 3/2. So we'll have -3, and 3 times 3/2, that'd be 9/2. 1 times 3/2 is 3/2. 2 times 3/2 is 3. 1 times 3/2 is 3/2, and 2 times 3/2 is 3. Horizontal compression by 1/2. I'm going to multiply all of these x coordinates by 1/2. So we'll have -3/2, -1/2, +1/2, 1, and then +3/2. And that's it. And then we would just, if we were graphing, we would graph the new points. Reflections. Remember, if we're reflecting over the x-axis, I'll do a little sketch for you. Remember that if we've got our little coordinate plane here, the x-axis is the horizontal axis, but if I'm reflecting over the horizontal axis, that's a vertical change. So that means that the y values are going to change sign. So we'll have -3, -1, -2, -1, -2. Again, not that difficult. And the nice thing about this is we're going to talk about this with lines. We may talk about it again when we talk about quadratic equations or parabolas. You're definitely going to talk about it when we talk about exponentials and stuff like that. The rules don't change. The rules are always going to be the same. So you're going to see these rules come up again and again and again. And hopefully by the end of the class you will remember them. But we'll see. Now there are story problems. What is math without a story problem, right? So let's see what this one says here. We have George has a goal for the number of computers he wants to sell each month for the next 6 months. He draws a graph to show his projected profits for the period. He decides to discount prices by 10%. How is this going to affect his profits? Identify the transformation and describe how to find the ordered pairs for the transformation. All right. So remember, we've talked about this before a couple times, I think. But like if I've got something on sale, if I pay full price, remember that's 100%. So if I'm discounting, I'm subtracting 10%, which means I have 90% of my original price. Now you would think, oh, subtraction, that's got to be a translation. But what we're doing here is actually we're going to multiply by 0.9. So it's going to be like 0.9 times the price. So really what this is a compression. And I think it's going to be, how is this going to affect his profit? Well, profit is how much money you make from sales, right? So discounting everything by 10% is going to be a vertical, whoops, let's not try to write with the highlighter. It is going to be a vertical change. It's going to be a vertical compression. So basically what's going to happen here is it's going to be, instead of xy, it's going to be x and 0.9 y. Because he may, x is the number of computers. Is x, y would be the cost. Because that's where his profits are, right? So money, money, money. So if he sells the same number of computers and they're all discounted 10%, he's only making 90% of what he would otherwise. So vertical change. Gotta think about it. And it may help to actually graph things. We don't have the formula. We don't know how much he's selling, or we don't know how many he sells in a month. We don't know that, so it's kind of hard to come up with an equation or a set of points to graph, but you know, we could do hypotheticals. I'm not about that. So that's it. That is the lesson. Not too shabby, I hope. Your assignments in the Schoology folder. If you learned something, make sure you smash that like button, and I'll see you in the next one.